Welcome back to the 60-day Bash Security Challenge. Yesterday we set up our environment and learned how the shell processes commands. Today is day 2, and we are tackling variables and data types. I put data types in quotes because Bash barely has them. Every variable in Bash is a string. When you write x equals 42, Bash stores the characters 4 and 2, not a binary integer. This matters for security more than you might expect, and I will show you exactly why. Let us start with assignment. In Bash, you write the variable name, =, and value with no spaces. That no spaces part is critical. If you write target equals 10.0.0.1 with spaces around the equal sign, Bash does not assign anything. It tries to run a command called target with equals and the IP as arguments. You get a command not found error, and your script keeps running. Now imagine that variable was supposed to hold the IP address you are scanning, or the path where you are writing logs. If it never gets set, every downstream operation using it will behave unpredictably. No error, no warning, just broken logic. Now let us talk about quoting, because this is where real vulnerabilities live. When you reference a variable without quotes, Bash does two things to the value before passing it along. First, word splitting, it breaks the value on any white space. Second, path name expansion, it matches any glob characters like asterisks against file names. Both of these are security problems. Here is a concrete example. Say you have a variable called user input that contains the string hello cat etc shadow. If you pass that to grep without quotes, Bash sees the semicolon as a command separator. It runs grep hello, then runs cat etc shadow as a completely separate command. If you wrap the variable in double quotes, the entire string including the semicolon is passed as one argument to grep. Grep tries to find that literal pattern, fails, and nothing bad happens. The fix is simple. Every single time you reference a variable, wrap it in double quotes. $ variable name, always inside double quotes. Single quotes are different. They prevent all expansion. $, backticks, everything inside single quotes is literal. Use single quotes when you want to define a regex pattern or a string that should not be interpreted. Bash gives you declare and read-only for adding constraints. Declare -i marks a variable as integer, but do not trust it for validation. If you set a declare -i variable to a non-numeric string, Bash silently converts it to 0. No error, no warning. If that variable controls how many times your script retries a connection or how long it waits before timing out, an attacker who can influence the input just set your timeout to 0. Always validate input with a regex check before using it in arithmetic. Read-only is more useful for security. Once you mark a variable as read-only, nothing can change it, not even your own script. Use it for configuration paths, for log file locations, for anything that should be set once and never modified. If an attacker manages to inject code into part of your script, read-only variables cannot be tampered with. Arrays in Bash are important for safely handling lists. When you declare an array and loop over it, use the syntax $curly brace array at curly brace quote. That quoted @ expansion preserves each element as a separate word without resplitting. If you skip the quotes or use asterisk instead of @ all elements merge together and split on white space again, which brings back every vulnerability we just discussed. Associative arrays, available in Bash 4 and later, let you build key-value lookups. They are useful for tracking things like failed login counts per IP address or mapping hostnames to status codes in a monitoring script. One more critical topic: environment variables. When you export a variable, every child process can see it. On Linux, any process running as the same user can read another process's environment from proc PID environ. So if you export a database password or API key, it is readable by every tool your script calls and potentially by other processes. Better approaches include passing secrets through STIN, using file descriptors, or using a secrets manager. At minimum, be aware of what you are exporting and why. To recap day 2, every variable is a string, always double-quote your expansions, do not trust declare-i for validation, use read-only for configuration, and be careful about what you export. Tomorrow we hit conditionals and test operators, where we start using these variables to make decisions in our security scripts. See you then.